Greetings, pre-algebra students. Today we are going to work on triangles some more. We have been working on right triangles. This is a review of what you should have done and what you should know. You should be able to find the hypotenuse, area, and perimeter of a right triangle with these legs of 22 and 120. You should be able to determine if a triangle is a Pythagorean triple given the lengths of the three sides. And you should be able to calculate any missing length on the sides of a triangle. You could try that out. The answers are down here if you want to freeze the screen and try that out. But that is prior knowledge that you need to know. Today we're going to talk about special right triangles. There are two special triangles that we're going to talk about today. The first one is the 45, 45, 90. And there's a picture of it. Obviously, if you have a right triangle, if one's 45, the other has to be 45. Because these angles are the same measure, these sides have to be the same measure. You'll learn that later on in geometry to prove that. Using the Pythagorean theorem, we want to find what C is. I'm going to develop the rule here. 1 squared plus 1 squared equals C squared. That's using the Pythagorean theorem. We evaluate that, and we got 1 plus 1 equals C squared, so C squared equals 2. And C is the square root of 2. What that tells us is that in any 45, 45, 90 triangle, C is always the square root of 2 times the length of the leg. I'm going to write L there for the length of the leg. This, of course, is an isosceles right triangle. Here I've used a unit triangle, which just means measures of 1 on those legs. These are the legs. That is the hypotenuse. Now let's go on and look at another example. Now, in a 45, 45, 90, if you identify your legs, the length of the legs as x, then the hypotenuse has to be the square root of 2 times that x, always. So now, if you have this special case, you don't need to keep going through the Pythagorean theorem. You can just use this rule, that the hypotenuse is equal to the leg times the square root of 2. Now, if you're given the hypotenuse, you can also use this formula to find the length of the leg. This is going to be handy because we often don't simplify our radicals when we're dealing with geometry and sciences. Let's move on to a word problem. The infield of a softball field is a square and has a side of 60 feet. Here's the side of the infield. It's 60 feet. The catcher is going to throw from home plate to second base. Why? Throwing out a steal at second. How far does the catcher have to throw that softball? Well, that is the hypotenuse of a 45-45 right triangle. So let's use the rule. The hypotenuse is equal to the length of the leg times the square root of 2. The length of the leg is 60 feet. Square root of 2 is 1.414. Plug that in. You can use a calculator on that. And answer the question that is asked, please, which is the catcher has to throw the ball about 85 feet to the nearest foot. Okay? Always answer the question that is asked. I'm going to give you another example. I want you to freeze your video, pause it, and work on this one. A city park is shaped like a square with a side of 150 feet. What's the diagonal across? You have to run the diagonal. How far do you have to run? Solve that one, and then I'm going to put up the answer. Here we go. Always draw your picture. That is required. You know that. You should know that you need to draw a picture for me. 150-foot square. C is our diagonal. C is going to be 150 feet, which is the leg, times the square root of 2. Plug that into my calculator. I get approximately 212 feet. Please answer the question that's asked. The distance across the park is about 212 feet. So that is the 45, 45, 90 right triangle. I told you there were two special triangles we were going to work with. The second one is the 30, 60, 90. In the 30, 60, 90, the shortest side is always opposite the smallest angle. The smallest angle is 30 degrees, and the smallest side is opposite that always. So that is going to be x. The hypotenuse is the longest side in any right triangle, and that is double the shortest side. So if this is x, the hypotenuse has to be 2x. And this is going to be the square root of 3 times x. Let me write that a little neater. The longer leg is always the square root of 3 times the shorter leg. So the hypotenuse equals 2x, and the longer leg is x times the square root of 3 in any 30, 60, 90 right triangle. That'll save you a lot of work not to have to use the Pythagorean theorem. This is very common in SAT test, in standardized test, in the math counts competition. A lot of things like this show up. You need to know that shortcut to save you the time and not use the Pythagorean theorem. So let's look at a practical example. Here's our 30, 60, 90 triangle over here. We have a side of x. I don't know if you can see that. That's the shorter side. And we have a longer leg. That's y. We need to know what x and y are, what the length of those legs are. Well, in order to do this, what do you think you need to do first? We know the hypotenuse is 10 units. I want you to give some thought. Which one do you want to find first? Right, we want to find the x first, because the length of the shorter leg is half of the hypotenuse. Let's take our formula. The hypotenuse equals twice the shorter leg. Plug in the hypotenuse length, use x for the shorter leg, and x comes out to 5, which is half the hypotenuse. So now you know that x equals 5 units. Now can we find y? Sure we can. Go back to the second part of the second formula on the 30, 60, 90. The longer leg is equal to the shorter leg times the square root of 3. The shorter leg is 5 times the square root of 3. We're going to substitute that in, and we're going to leave this as in radical form. The shorter leg is 5 units long, and the longer leg is 5 times the square root of 3, and that is your answer. I have 2 practice ones. You can pause your screen and work on those, and I will pop up the answers, and that's going to wrap it up for today. There are the solutions to those. You paused your screen and worked on those. Please remember, when you're doing your work for me, you must draw your pictures and list your data. Always. So have fun using those special cases. Those are very helpful.